Hello everyone, welcome back. It's good to see you. I hope you're doing well, staying healthy, staying positive during this weird time. Keep going strong, all right? We only have a few more weeks left in the school year. If you are a senior, you only have really maybe 2 or 3 weeks more left to go. Keep that momentum going, keep going strong, you're almost there, all right? We are going to talk about this week arithmetic and geometric series. Last week we talked about sequences, and now we are talking about series. So stay on your toes in the beginning of this presentation because I'm going to talk about that difference, and you need to make sure you understand what that difference is before we head into examples. Let's jump into it. Your assignments this week. As normal, you have a classwork assignment on Teams. It is 10 questions this week, 20 points. And then you have a Khan Academy assignment on Khan Academy. That is 4 objectives that week. But this week, worth 4 points in focus, and the list of the titles of the assignments are right there for you. I would suggest going in this order that I have listed on the PowerPoint, and that's what I'm going to be sticking to as far as my order goes in this presentation. Quick review of last week. We talked about sequences, more specifically arithmetic sequences and geometric sequences. Let me grab a drink. This is the third time that I've started the video over because I've made mistakes. So hopefully I won't have to do it again. But that's why I'm already thirsty. Anyways, arithmetic sequences. They are a list of numbers that have a constant difference, meaning that they are addition patterns. An example of this would be 2, 5, 8, 11, 14, because you are adding 3 between each number. A geometric sequence, on the other hand, is a list of numbers that have a constant ratio, meaning it's a multiplication pattern. 2, 6, 18, 48, 144. This is a geometric sequence because you multiply by 3 between each number. So now we're talking about series. So what is the difference between a sequence and a series? A really, really important point that you have to know. A sequence is just the list of numbers. However, a series is the sum of that list of numbers. Put an addition sign in between each number in a sequence and you have a series. An example with an arithmetic sequence such as 1, 7, 13, 19 could just be changed to an arithmetic series by adding plus signs in between each number. 1 plus 7 plus 13 plus 19, this would be an arithmetic series. A geometric example, a geometric sequence could be 64, negative 32, 16, negative 8, 4. You're multiplying by negative 1/2 in between each number. If you wanted to make that a series and find the sum of it, just add plus signs in between each number. 64 plus negative 32 plus 16 plus negative 8 plus 4. That's the difference, that's it. So our first objective for the day out of 3, we have 3 objectives with examples that follow after each one, is finding the sum of a finite geometric series. If I give you a list of numbers, more specifically a list of numbers with a multiplication pattern, how do you find the sum? When I say a finite geometric series, that means that it is going to be a geometric series that has a start and an end. Finite as opposed to infinite being the opposite of that, right? Infinite goes on forever. We do not talk about those in Algebra 2 for right now. That'll be more pre-calculus material, I believe, for you guys. We are sticking to geometric series that have a start and a finish, that have a finite number of terms. So for any finite geometric series, you can find the sum of the terms in that series. You can use a calculator for sum. Like you can do 3 plus 6 plus 12 plus 24 plus 48, which we're going to be doing in our next example that I have written in front of me. But oftentimes, there's going to be too many numbers in your series to just plug it into a calculator, so you need a formula to help you make the process more efficient. And that's this formula right here. I would argue this is the most important slide, or one of the 2 most important slides in this presentation, so please make sure that you get it down. in your notes. We read this off as Sn equals A1 times 1 minus r to the n power over 1 minus r. It looks intimidating at first, but you know pretty much all of the terms in this formula, what they already mean, except Sn. You haven't seen that before. Sn is just the variable that we use to represent the sum of the geometric series, which is usually what you are going to be solving for this week. S means sum. What is the sum of the series? Okay, and then A1, R, and N, you already know what those are from the previous week. A1 is the number that's the first term in your geometric series. R, excuse me, is your common ratio, and N is the number of terms in the series. And now that you have that formula, we are ready for our examples. All right, so let's move to my iPad. Please make sure that you're taking good notes. This stuff is tougher than last week for sure. So you want to be taking those notes so you know what questions to ask in the future. All right, here we are. Example number 1, we're going to start off simple, all right? Find the sum. 3 plus 6 plus 12 plus 24 plus 48. Is this a geometric or an arithmetic series? The answer is geometric because you are multiplying by 2 in between each number. 3 times 2 is 6, times 2 is 12, times 2 is 24, and so on. Now, for those of you who are saying, Mr. Kahn, we don't need to use that formula, right? That crazy formula with the A1, the R, the N, the Sn, we don't need to use that for this, right? Can't I just put this in my calculator? And the answer is, yes, you are smart. We can just do that. If I plug this into my calculator, I get the answer of 93. Try it out on your own, just so I'm not making a mistake, right? But you should be getting 93 if you plug those numbers into your calculator. We're not going to say example 1 is done, though, because I do want to show you how this new equation works. We should get Sn being 93 in the end, but I just want you to follow along with me with this relatively simple example so you can see how the equation works. All right, so I'm going to use different colors for my different variables here. First in red, A1. Oh, first, actually, let me highlight what we're actually solving for. Sn is the sum of our series in this formula, and we don't know what that is. That's what we are trying to find. We should expect it to be 93 in the end. Let's hope that we get that, right? So anyways, moving on. The first thing that I underlined here in red is A1. If you looked at the PowerPoint or remembered from last week, A1 is the variable used to represent your first term. What is your first term in this short series? It is 3. So I'm going to say A1 is equal to 3. Okay, next variable is R. What does R represent? That means your common ratio. What number are you multiplying by between each term to get the next term? And we already said that we are multiplying by 2 in between each number in this list. So R is equal to 2. Finally, the last variable that you need to know to utilize this equation is N. What is N equal to? N represents the number of terms in your series. How many do you have? Well, count them off with me. We have 1, we've got 2, 3, 4, 5. There are 5 terms in our series, so N is equal to 5. And now that you know what A1, R, and N are equal to, you can find the sum utilizing this formula. And remember, we're just doing it this way so you can see how the formula works. We should expect 93 to be our final answer. Let's see if we get that. All right, first of all, A1 is 3 times 1 minus r to the n. So r is 2, n is 5. So 1 minus 2 to the 5th power. This is all divided by 1 minus r. And again, r is 2. So now we plugged in our formula, we plugged in our numbers for this formula, for those variables, a1, r, and n. And now we just have to evaluate moving forward what this is equal to. Please make sure when you are simplifying that you follow the order of operations. But other than that, it's pretty straightforward. You can use a calculator to assist you. Do that exponent on top first, this exponent right here, okay? Simplifying, moving forward, 3 times 1 minus 2 to the 5th. Go into your calculator or just do it in your head. 2 times 2 times 2 times 2 times 2. 2 to the 5th is equal to 32. And then on bottom, 1 minus 2 is negative 1. Moving forward, 1 minus 32 is negative 31. Negative 31 divided by negative 1 is just a positive 31. And 3 times 31 is indeed 93. The answer that we are expecting all along. If you're still asking, Mr. Khan, what's the point? We could have just used our calculator, all right? Yes, you can use your calculator for some problems, but you will see later on in this presentation that sometimes you will not be able to use your calculator because you are adding together dozens or hundreds of terms even. This is a relatively straightforward example, just getting help using that equation. Let's move forward. All right, so find the sum of the first 9 terms in the series. 1, negative 5, 25, negative 125, dot, 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 which just means this dot, dot, dot here, y'all, that just means that the pattern continues, right? So what is the pattern, by the way? Well, we got to figure that out. This is a geometric series, meaning we're multiplying by something in between each number. I see that it's switching between positive and negative between each number. So I know that my r value is a negative number. And what am I multiplying by in between each number to go from here to here or from here to here? I'm multiplying by a negative 5. So that's going to be valuable to know later on. Let's write out our formula for finding the sum of a geometric series once again. The formula is Sn equals a1 times 1 minus r to the n power over 1 minus r. And now we find what a1, what r, and what n are equal to. So we can plug it into this formula and solve, just like we were doing before. Okay, first, a1. a1 is the first term in your series, which is 1. r. We already established what r was equal to. It was equal to negative 5 because you were multiplying by negative 5 in between in between each number. And then finally, what is n? N is the number of terms in the series, and even though this goes on forever, we're only adding the first 9 together, right? It says find the sum of the first 9 terms in the series. That means that n is equal to 9. Same as before, y'all. Take what you have, these 3 constants that you're going to plug in for those variables, plug them in and evaluate, and you will get the sum of your series. a1 times 1 minus r to the n power over 1 minus r. We are plugging in a1 first, which is just 1. That makes things easier, which is nice. Times 1 minus r to the n power. Be careful with that negative sign. We're going to put that in parentheses. So r to the n power is negative 5 to the 9th power. And that is all divided by 1 minus r, which in this case is 1 minus negative 5. Excuse me. And now just move forward and simplify as usual. Take care of the exponent first, then do the subtraction, divide, and you're at your answer, right? Feel free to pause the video at any point so you can work on it before I get to the answer, if you're that type of person. Anything multiplying by 1 just stays the same, so I don't even need to write that 1 again. I'm just going to do 1 minus whatever negative 5 to the 9th power is. Be careful, it's going to be definitely a large number. Negative 5 to the 9th power is equal to, holy camole, such a big number. I'm going to actually need more space here. Let me go down below. Negative 5 to the 9th power is actually negative, and we'll figure out how to say this later, 1953, 125. Wow. So that's, let's see here, 1,953,125. That's what negative 5 to the 9th power is. Crazy. And then it's over 1 minus negative 5, which is 6, right? Double negative makes a positive. So on top, we have 1 minus negative 1,953,125. That changes to a plus sign because of the double negatives, right? This is going to be a plus right here. So on top, you're going to have 1,953,126, we just added 1, divided by 6. Do that division problem in your calculator, and we will arrive at our final answer. Let me do that over here in my calculator. 1,953,126 divided by 6 is equal to 325,521. That is the sum of the series. So you can see here, you probably don't want to be plugging that all into your calculator, right? Even though it's just 9 terms, it's getting pretty large. It's easier to use the geometric formula that we're learning for the first time today. 325,521 is the sum of that series. Sorry, that's me drinking my smoothie. All right, let's continue. Example 3. The first term of a geometric series is 128, and the common ratio is 0.6. Find the sum of the first 5 terms. So here you are not given a list at all. However, you are given all of the information that you need. So this, I would argue, is actually an easier problem. Except for the fact that we're going to end up with a decimal answer, but that's okay. All right. So anyways, the first term of a geo series is 128. This is going to be my A1 value. The common ratio is 0.6. This is my R value. And finally, it says find the sum of the first 5 terms. That's going to be my N value. And I'm going to be plugging those things into the same exact equation that I used before. All right, so the sum of the series is equal to A1, which is 128, times 1 minus R, which is 0.6, to the n, which is 5, over 1 minus r, which is 1 minus 0.6. Evaluate the top first, 1 minus 0.6 to the 5th power is going to be 0.9224. Make sure you keep all of those significant digits in. I actually missed one as I say that. 92224. And this is divided by 1 minus 0.6, which is 0.4. And you obviously have to utilize a calculator here, right? So we go into our calculator, we do 0.92224 divided by 0.4. I get 2.3056, and we are going to multiply that by 128 in our next step. So multiply by 128, that gives us our final answer of 295.1168. That is the sum of my series. Why do we get a decimal in this, this time around? Well, we're multiplying by 0.6 in between each term in this series, which means that we are going to have some decimals in our list, right? That's why we get a decimal answer. Final sum is 295.1168. All right. And this says example 5. We're skipping example 4 for right now because it was very, very similar to the one that I just did. This is a little bit different because you're actually finding something that's not the sum. You're actually finding the first term in this question. You are going to utilize the same equation, but you're just solving for something different. So let's read this problem off together. It says, find the first term of a geometric series with r equals 4, n equals 5, and a sum of 682. So in this problem, we are going to be utilizing the same equation. However, now the question asks, find the first term, which means that this right here, A1, that is what we do not know. Right? That's our unknown. So that's going to stay A1, and that is what we are going to eventually solve for. What is Sn equal to? Sn is equal to 682. So I'm going to plug that in. A1 stays the same because we do not know what it is. That's what we're solving for. Times 1 minus r is 4. To the n power is 5, divided by 1 minus 4. Let's now evaluate what this is equal to, this fraction. We're going to leave the 682 is equal to A1 the same. All right, that's just staying the same. So let's go into our calculator and do 1 minus 4 to the 5th. First of all, 4 to the 5th power is 1024. 1 minus 1024. Oops. Okay. I am going to move over here now. So 1 minus 1024 is going to be negative 1023, divided by 1 minus 4 is negative 3. Okay, now let's actually do that division. Negative 1023 divided by negative 3. Negative 1023 divided by negative 3 is equal to, that is not right, give me 1 second, negative 1023 divided by negative 3. That is not right either. Let's just do positive. There we go, 341. Negative divided by a negative is positive. All right, so 341. And then to find A1, divide by 341 on both sides of the equation. $682 divided by 341 will come out to our first term being equal to 2. And now we are ready to go back to the PowerPoint for objective 2. All right, so next thing that we're going to be talking about is something called summation notation. A simple way of defining this, of thinking of summation notation, is just a more simple and concise way, a shorthand way of writing a geometric or an arithmetic series. It uses a special symbol. You've probably seen it before, but may not have known what it means in a mathematical context. It's called a sigma sign, all right? And that's what we're going to be using when we take summations. This is what a I should have deleted this. This is what a sigma sign looks like. You're going to have this kind of crooked E symbol, all right? That's called a sigma sign. You will have k equals some number on the bottom. It will usually represent, or usually it will say k equals 0 or k equals 1. This is your lower limit where to start in the series. Then you're going to have some number on the top. That's called your upper limit, where to stop. And then you have the argument over here, which is the expression that'll be added over and over again. I understand that it's kind of hard to look at this and know what's going on. So we're going to go over a couple of examples of just showing you how to use summation notation. It's a lot easier than it looks, I promise. So this is objective 2. We're ready to move back into examples now. And we're practicing here with summation notation. Okay. Example 6. Evaluate this. It says, this is summation notation here. We have a starting value of 0 and an end value of 7. And our argument is 8 times 1/2 to the n power. What does this mean? Yikes. Okay, so first of all, what this actually means is that we are going to start at k equals 0, and we are going to plug that in for n. All right, so the first term that you would have is 8 times 1/2 to the 0th power. And then you go up to 1, and you plug in n equals 1. So you'll have plus 8 times 1/2 to the 1 power. And then you go up to 2, and you have plus 8 times 1/2 to the 2nd power, plus 8 times 1/2 to the 3rd power, plus 8 times 1/2 to the 4th power, and you keep going. You keep adding these 8 times 1/2 to the n power until you reach your end number, which is 7. So you do plus 8 times 1/2 to the 7th power, and then you would stop. This is not something that you should just plug into your calculator because there's way too much going on here for you to type that all in. You are still going to be utilizing in this example the same equation that we were talking about before. Remember that summations, when they're written in the sigma notation, summation notation, it's just the same thing as a series. Oops, sorry about that. If you want to find the sum of this series, you are going to be utilizing the same exact equation, all right? Now, the tricky thing is with this new notation, you got to know where to find your A1, your R, and your N values, right? First of all, what is A1? A1 is your first term. Oops. A1 is your first term, and A1 in this case will be 8. In a geometric series, it's always that number on the outside of parentheses. All right, so we are going to say A1 equals 8. Next is R. What is your R value? R is just this 1/2, the base of your exponent in summation notation. All right, so we're multiplying by 1/2 each time in this series. That's what that notation means. And then finally, what is N? N is the number of terms in your series. How many integers are between 0 and 7? Well, count them out. You have 0, 1, 2, 3, 4, 5, 6, 7, which is actually 8 integers. There would be, from 0 to 7, there would be 8 terms in this series. So N is equal to 8. So we'll have 1 minus 1/2 to the 8th power over 1 minus 1/2. Plug this into your calculator, find what the summation is. 1 minus 1/2 to the 8th divided by 0.5, or 1 minus 1/2, times 8 is going to come out to 15.9375. Let's go over another one here. All right. Let's say that we have k equals 1 to 72 with an argument of -7 times -8/9 to the n minus 1 power. If we want to find the summation of this series, we are going to do the same exact thing. First of all, what is A1? A1 is your first term, which in this case will be -7. Okay, times 1 minus r to the n. What is r? R is whatever number is the base of your exponent. So it's this -8/9 right here. To the power of n, what is n equal to? Do that in purple again. N is equal to how many numbers exist between 1 and 72, right? So there are 72 numbers, including 1 and 72, integers between 1 and 72. So we are going to say n is equal to 72, which is what we plug in right here. Divided by 1 minus r. R again is -8/9. And this will be what we plug into our calculator to solve. First, I'm going to do what is on top. 1 minus negative 8/9 to the 72 power. Please make sure that you utilize those parentheses. I get a super long fraction here. I'm going to divide that by 1 minus negative 8/9. And that gives me 0.529302. I'm going to multiply that by that -7, and I'm going to arrive at my final answer. Negative 3.70511 is my final sum for this series. We're about to jump into our last objective, but the main takeaway here, y'all, just to sum this up, please make sure that when you are plugging these numbers into the formula, that you follow the order of operations and that you use a calculator, right? We got a lot of decimals going on here. We got high exponents. So if you don't have a scientific calculator with you, then utilize Desmos, and that's a huge help. Let's move on to our last objective. All right, so we talked about geometric series for a majority of this video because it is the hardest type of series to deal with, but we also have arithmetic series, which we can find the sums of, all right? So remember that geometric series have a multiplication pattern in them, but arithmetic series have an addition pattern in them. It has a separate equation, but thankfully this is a little bit easier to use than the other one, and it reads off as follows. Sn equals n times a1 plus an divided by 2. This is the equation for the sum of an arithmetic series. You cannot use this for geometric series, and you cannot use the geometric formula that we just used for an arithmetic series. They are separate. So for this formula, what do each of those variables mean? First of all, Sn still represents the sum of your series, but now it's an arithmetic series. N is the number of terms in your series. That's the same as well. A1 is the same. It is the first term in your series. The only thing that's new in this formula is that you don't have R, that's the constant ratio. What you actually need in this formula is A sub n, which is the last term in your series. What you're going to do is you're going to essentially take the average of the first and the last term in the series divided by 2. Like once you add them, divided by 2, that's the average of them, and then you multiply by n. That's going to give you the sum of the series. And this is going to bring us into our last examples of the day. So make sure, again, I know it's been a little bit longer of a presentation. Make sure you're paying close attention here, taking good notes. If you want to take a pause, totally hit pause on the video, grab something to eat, whatever, and then come back. Just so you know you're in the right mindset for this last objective. Okay. Example 8. Find the sum of the first 600 terms in the sequence. You can see here that we have two formulas in this problem. Remember that this is called a recursive formula, right? In this series, your first number is 2. Every number after it, you have to add 4 to get it. So if we were writing the list of numbers, even though it looks confusing right now, all this represents is it represents 2, 6, 10, 14, 18, and so on. We're going to be adding all of these numbers together. How many numbers are we adding together? We're actually adding, I know it sounds crazy, we're adding 600 of them together. Our number is going to be super big. How do we do this? All right, so what we're going to do is we are going to do our formula. Sn is equal to A1 times, and I started doing my geometric, silly me. Let's go back to the formula so I don't mess it up. N times A1 plus AN over 2. All right. So first of all, how many terms do I have in my sequence? That's my n value. My n value is 600. That's what I'm going to plug in for n. Times A1. What is A1? A1 is the first term, and it's given to us. It's right here. The first term in our series is 2. So I'm going to have 2 plus AN is the last term in my series. What is the 600th term in my series? Well, we're going to have to do a little bit of math to figure that out, right? Our explicit formula for this problem will be A sub n equals A sub 1 plus D times n minus 1. If you're confused about where I pulled that from, this equation right here is from last week. This is the explicit formula for arithmetic sequences. So if we were wondering what is the last term in this sequence, meaning what is the 600th term in this sequence, that means that AN will equal to A1, which is 2, plus D, which is 4, we're adding 4 in between each, times 600 minus 1, which is 599. Do that in your calculator. 599 times 4 plus 2. That's going to come out to 2,398. That's what AN is equal to. We're dividing that by 2. All right. So we do this in our calculator. First thing that we do is this 2 plus 2,398. 2 plus 2,398 is 2,400. Then we divide that by 2. Gives us 1,200. And then we multiply by 600. And I just multiplied it by the wrong thing. Give me 1 sec. Divide it by 2 times 600 is going to give us the sum of that series. The sum of this arithmetic series, the first 600 terms in this series, is 720,000. We have one more example after this one, and then we're good to go. All right, so it says here, find the sum. And now we have a list of numbers. It's not just 5 terms though, because we have this ... here, right? So we need to find the sum of this series. It says 807 plus 802 plus 797 plus ... plus 137 plus 132. This is an arithmetic series because our common difference is -5. We are decreasing by 5 in between each number. 807 minus 5 is 802. 802 minus 5 is 797. And then we continue that pattern. We keep subtracting 5 over and over and over and over again until we get to 132. So let's use our equation and figure out the sum of this arithmetic series. Sn is equal to n times a1 plus an over 2. Okay, first thing, what is n equal to? Well, this is a really hard question to figure out, right? Because we have 807, 802, 797, and then it just continues forever. I'm sorry, not continues forever. It continues a long time through the 600s, the 500s, the 400s, the 300s, the 200s, until we reach 132, right? 132 is our last number. So how many numbers are in this series between that start number of 807 and that end number of 132? What you need to do is just a very simple equation to figure out the answer for this, all right? What you're going to do is you're going to do 807, the first number, minus 132, the last number, and you're going to divide it by the common difference. After you get that number, you're going to have to add 1 to it to include the first number, and that's how many terms you have in your sequence. 807, let's do that on this one so you can see it. 807 minus 132 divided by 5 is equal to 135. And then we have to add 1 to get 136. That's how many terms are in this sequence. That's our n value. Next, what is A1? A1 is the first term in your series, which is 807. Next, what is AN? AN is the last term in your series, which is this 132. And now you have everything you need to plug it into your formula and move ahead and solve for the sum. So S of n is equal to n, which is 136, times a1 plus an, which is 807 plus 132, divided by 2. Go to your calculator, do 807 plus 132, divided by 2, times 136. And we will get 63,852. The sum of the first 136 terms in that series from 807 to 132, decreasing by 5 with each number. And this is my last example for the day, y'all. Please make sure with this complicated material that you're asking questions in teams if you are struggling. Although last week I expected a lot of you to get done with it just completely on your own because it was more straightforward, that is not the case this week at all. You should be logging onto the video chats. You should be seeing me work through problems with students so that you can latch onto that and get the highest grade possible that you can on your classwork and homework for the week. I hope you all have a good week, and I will talk to you later.